So let's discuss the electron matter interaction in more detail here. As you know, the specimen is made of atoms, and the atoms, they are either from the low atomic number or the higher atomic number. The differentiation between the high atomic number and the low atomic number is very much simple. The atom with the low atomic number as compared to the atom with the high atomic number, in case of atom with the low atomic number, the nucleus is a bit smaller as compared to the atom with the high atomic number. It means if the high energy electron beam which is emitted by the electron gun, if they interact, if this high energy beam interact with the atom with the smaller nucleus, will be much, the interaction will be much different from the atom with the high atomic number. You can imagine that if the high energy beam, if they interact with the matter which is composed of low atomic number, means the smaller nucleus, then the depth of penetration will be much more as compared to the specimen which is comprised of high atomic number, because in case of high atomic number, the bigger nucleus, it will be a big hurdle for this high energy electron to get penetrated in the specimen. So bigger is the nucleus, bigger is the hurdle for electron to bypass it. So to discuss how these electron matter interaction happen in case of secondary electron, backscatter electron, and the X-rays, are going to discuss in this specific slide. So in case of secondary electron, the only importance is of the surface. So what is happening, that if a high energy beam electron interact with the surface atoms of the specimen, then they impart energy to the atoms. This means this energy is transformed in the way that the outermost shell of the atom, which is comprised of the electrons, they will be knocked out. If these electrons are knocked out, then these electrons are detected as a secondary electron, and these are only from the surface atoms. So either low atomic number specimen or the high atomic specimen, the specimen comprises of low atomic number or the high atomic number. In both the cases, in case of secondary electron, they are same, because in case of secondary electron, we are only dealing with the surface atoms and nothing more. So the beam of electron, they impart energy to the atom, the surface atoms of the low atomic number or the high atomic number, and then electrons from the outermost shell of the atom, they will be knocked out. So the depth of penetration in case of secondary electrons are the least important, because we are getting these secondary electron only from the surface atoms. So either low atomic number or the high atomic number, it doesn't matter in case of secondary electron in principle. Whereas in case of backscatter electron, what is happening here, the high energy electron, they get penetrated from the surface atom to the bulk, and then if the specimen is of low atomic number, means the smaller nucleus, then the penetration, the depth of penetration of electron beam, the high energy electron, will be much more as compared to the high atomic number specimen, because in case of high atomic number specimen, the bigger nucleus is a bigger hurdle for these electrons. So if this bigger hurdle get interacted with the high energy electron, then they will deflect it back sooner than the specimen with the low atomic number. So if high energy electron beam hit this sample, and the sample is comprised of low atomic number, atoms, then the depth of penetration is much more in case of backscattered electron, and then these high energy electron penetrate inside to the sample and then they will be deflected back. Whereas in case of high atomic number specimen, these electron beam are deflected much earlier as compared to the low atomic number. The third thing is about the X-rays. The high energy beam electron, they penetrated to the surface inside the bulk, and then the phenomena of X-rays happening here. So in case of X-rays, the depth of penetration is much more of this high energy beam in case of low atomic number as compared to the high atomic number. This thing is very much similar to the backscattered electron. So what is happening, if these high energy electron, they are moving inside the bulk, they penetrate from the surface inside the bulk of low atomic number. So if the specimen is comprised of low atomic number, the depth of penetration will be more. If the sample is comprised of high atomic number, then this depth of penetration will be much smaller comparatively to the specimen which are comprised of low atomic number. To sum up the discussion, the specimen with the low atomic number is compared with the high atomic number, and how these three electron matter interactions happening here. The secondary electron, in both cases either low atomic number or high atomic number is same, because secondary electrons are emitted from the surface atoms. Second thing is the backscattered electron. The backscattered electron are deflected back, is a bit different in case of low atomic number than the high atomic number, because depth of penetration of this high electron beam is much more in case of low atomic number as compared to the high atomic number. Similarly, the depth of penetration for the X-ray, the X-ray phenomena occurs at a much higher depth in case of low atomic number as compared to the high atomic number. The last point that I will going to emphasize is that this penetration, either in case of backscattered electron or the X-ray, this is the pictorial representation. This does not mean that the high energy electrons are so much powerful that they penetrate throughout the bulk of specimen. Even this bulk, that the penetration of this high electron beam in case of backscattered electron or the X-ray, is this bulk is of couple of hundred of nanometers. So this doesn't mean that the high energy beam electron, they will penetrate throughout the sample. No, it's not happening here. Just this bulk means this penetration is a relative term as compared to the scanning the secondary electrons. The secondary electrons is only from the surface atoms. The backscattered is a little bit more than the surface, and the X-ray is a little bit more than the backscattered electrons. So these all are the relative terms. So I hope you understand this electron matter interaction. In case of any question, please raise your queries. To visualize and compare the images of secondary electron as compared to the backscattered electron, I took the opportunity to share 6 different images, and these 6 different images are coupled in 2 of each. So in couple of 2, one will be the secondary electron image and the other will be the image taken from the backscattered electron. So let's focus on top left hand side. So in top left hand side, the couple image are one from the secondary electron and the other from the backscattered electron. If you are only interested on the surface morphology, then secondary electron, the image formed by the secondary electron is more than enough for you. So you can see that there is a contrast, clear contrast between the background or the base with respect to some lump mass on the surface of specimen, and both these can be easily differentiated, and you can easily see that this baseline is very much flat, whereas this lump mass is a complex system. If you are further interested that how this lump mass look from inside, a little bit inside the surface, then the secondary electron microscopy image is supported by backscattered electron. So you have to take a different image of the same area from the backscattered electron. So detector who detect these backscattered electrons are taken into the consideration, and you will see this image from the backscattered electron detector. So in case of backscattered electron detector, you can easily identify that there is some complex system on this lump mass which are shown by which is shown in the secondary electron image. So in case of backscattered electron, this lump mass can be seen as there is a different bodies that are constitute inside this lump mass. In case of surface morphology of secondary electron, the lump mass, you can identify the lump mass with the base, but how this lump mass look from the inside, you cannot see it. Whereas backscattered electron, because the penetration depth is little bit more, so in case of backscattered electron you can see that okay, what's inside the surface, little bit inside surface. So there are different bodies comprises inside this lump mass. The second supporting image that I have taken is like the donut shape. So this donut shape shows the secondary electron, whereas this donut shape of the same object is showing the image of backscattered electron. So in case of surface morphology can be viewed by the secondary electron, you can see that there are islands of some objects on the surface of donut, whereas the backscattered electron, it penetrates a little bit more from the surface, and you can see that only the major cracks are visible, because these major cracks can be also seen in the secondary electron image formation, because these cracks are much more in depth. Therefore you can see these cracks in the form of lines only in case of backscattered electron image, but you cannot see the surface, how the surface actually look like. It can only be observed in the secondary electron image formation. So in case of secondary electron image formation of the donut shape, the island of lump masses are easily available or easily visible on the donut surface, whereas backscattered electron can show that these cracks that are visible on the secondary electron, they are much in depth, because as you know, in case of backscattered electron, the electron penetrate much deeper inside to the surface of specimen, and then they are bounced back or deflected back. So you can only see the cracks. Okay, these cracks are much more penetrated in this donut shape, but you cannot see the surface. Okay, how the surface look like, it can only be visible in the secondary electron image formation. The third images, the couple of image are supported in the right hand side. So in case of right hand side, there are two images, top and bottom. The top shows secondary electron image of an object, of the very same object, the image formation of backscattered electron. So in case of secondary electron image formation, you can see the contours, you can easily see the contours of the surface. So there are some trenches or some spots which are seen as a holes on the surface of the image, whereas in case of backscattered electron, you cannot see this variation of surface image as can easily be seen in the secondary electron. So in case of backscattered electron, because the electrons are penetrating much more deeper into the skin of specimen. So if they are penetrating much more deeper into the skin, then you will see a flat surface, not these contours. These contours on the surface can only be viewed in the image formation of secondary electron, not in the backscattered electron. In case of backscattered electron, you have a very clear contrast between these between the images, between the image of the very same specimen, and there are some artifacts. For example, if this is an artifact, then it can be easily distinguished with the base. Although this distinguished feature can be seen in the secondary electron microscopy with these trenches or holes which are not visible in the backscattered electron, but in case of backscattered electron, this contrast is much more prominent as compared to the secondary electron. But unfortunately, we lose the surface morphology features like these holes. In case of backscattered electron, we cannot see the surface topography or surface morphology in depth just as this, but we can just clearly observe the contrast of this artifact with respect to this base of specimen.